Hey Algebra 1 students, in this video we're going to graph a function rule. By the end of the video you'll be able to graph equations that represent functions. Alright, so the last lesson we were talking about analyzing graphs, or analyzing the function of a graph, and we could determine whether it was linear, straight, or nonlinear, non-straight. This time we're actually going to graph the function or the equation. Okay, sometimes it could be an expression, but in this case it's an equation. And in the last lesson they just gave us a table and we just plotted the coordinates. So I did that here. But there's actually something behind all this. There's a rule or a function associated with the data to get those values. Okay, so we've got the x value 0, but how do we get the output 0 and the input 1 and the output 3 and so on? There's a rule that is going on between, or we don't quite see it. So we're going to figure that out. The best way to do that is just to make a table. And pretty much this is all the lesson's going to be, is just showing you how to make a table of values to come up with a graph. So as a reminder, right, a function is going to have an input. Oops. Okay, you're going to have your input. We're going to just call it in, which is also our x values. And then you're going to have an output. So we'll just say out, and that will be your y. Now they've chosen just random numbers. Okay, 0, 1, 2, 3, and 4. All right. Now they're saying that when x is 0, y is 0. When x is 1, y is 3, 6, 9, 12. You get the point. Now in this middle section here, something is telling the x to change. It is changing the x, but what's happening? Well, how do we figure that out? We're going to call this, and this is kind of the mathematical way of showing this, is going to be the function of x. Okay, whatever that is. So right now we have 0 to 0. We're not quite sure. Well, what could that be? You could add 0. You could subtract 0 to get 0. Maybe you multiply it by any number and you get 0. There's so many different operations. That's what you kind of want to go through each one of these. So let's take the 1. What would we have to I would start out with adding. If we added 1 plus 2 would give us 3. Okay, now that rule has to apply for the second row. So we're going to take 2. We're saying we're adding 2 this time. Well, that doesn't quite work because 2 plus 2 is 4, but it's saying it should be 6, so it's not adding. All right, so you're going to back up again. You're going to figure out, well, what could it be? Maybe we try subtracting. Let's subtract, 1 minus 4. That would give us a negative 3, so that's not it either. Okay, so we did addition, we did subtraction. Just keep going through the operations. The next one would be to multiply. Well, 1 times 3 would give us 3. All right, well, let's try multiplying down here. 2 times 3 equals 6. We've figured out the rule. The rule right now, we're taking x and we're multiplying it by 3 for each one of these. What this means is that you're taking 3 and you're multiplying it by x. The function of x will be this, and I should rewrite this because I want you guys to understand that y will equal 3 times x. Okay, let's do the 0. So if it is 0 times 3, well, of course we get 0. All right, so now let's look at more examples on the next slide. All right, so here they gave us the function y equals negative 2x plus 1. They want us to graph this linear function using a table. Now, Later on, as we progress through Algebra 1, it's going to get a lot easier to graph these because there's a better method than using a table, but the standard says you will be able to use a table to graph. So this is what I've set up. I've got my table here. I've got my X and my Y, and then in between you've got the function. So we're really just evaluating at this point. We're going to come up with our own X values and then plug it in. So I'm going to list all these out right there. -2 times, well, we don't know what X is. We're going to come up with those values plus 1. That'll give us our Y values. So let's go ahead and fill this in. Where do you start? I would just say try to keep it simple. So in this case, like I would just start out with -1 as my first coordinate, followed by, just go in ascending order, 0, 1, and 2. Keep the numbers small so it's just easier when you go to solve these. So all you're going to do is now plug in right here, X is going to be -1. And then figure out what that is. -2 times -1 is going to give, that'll give us a +2. Try to erase this. Plus 1, that'll be a 3. So when X is -1, Y is 3. Let's go ahead and graph that. So we're going to go to -1. Remember, guys, you have to always start with your X. Now, when you're doing this in Math Excel, you really only need 2 points and the system will fill in the line for you. So it's pretty nice, but you really should know how to graph these. Okay, so going back here, -1, then we're going to go up 3. 1, 2, 3. So there's our first coordinate. Let's continue on. So let's plug in 0 and see what we get. -2 times 0 is 0 plus 1. That's going to be 0, 1. Let's go ahead and plot that. So we're going to go right to 0, which is the origin. We're going to go up 1, and then our coordinate will be right there. All right, let's do the 1. -2 times 1 is -2, plus 1 is a -1. So now we have 1, -1. Let's go ahead and plot that. We have 1. We're going to go down 1, and there we go. The last one, we're going to plug in 2 this time. -2 times 2 is 4, or excuse me, -4 plus 1, which is a -3. All right, so we're going to go over to the graph, and we're going to go to 2, and we're going to go down 3. 1, 2, 3, and we're done. Like I said, Math Excel it'll put the line in for you as soon as you have 2 dots, which is really nice. Now, as a reminder, all I did is came up with my own X values. You do not need to do the same thing I did. Feel free to do whichever ones you want. You could start out at 2, 4, 6. It really doesn't matter. Just keep in mind how many numbers you have on your graph. This one only goes to 10, you know, so I got to make sure that I have enough room. Okay, so this one's already done for us. It's the same thing, except for the difference here is that you have a function of y equals 1/2 x minus 1. So the same process, right? You make your table of values. You come up with whatever value for x, and then plug it into your function, the y equals 1/2 x minus 1, and then come up with your y value and go ahead and graph it. It's pretty simple. I think the only thing that might be confusing is, you know, what do you use for x? Just try to go with the most simplest numbers. Okay, so here's an example of an absolute value function. I know you've seen this before when we did absolute value equations. But really all we need to do is just fill in the chart or the table again and we're going to just graph it. So again, pick whatever x values you want. My graph it only goes up to 10, so I want to make sure that I go with lower numbers just in case. So I'm actually going to just start with probably like -1 and then ascending order, -1, 0, 1, and 2. Okay, so just going to plug in -1 here, right? X is now -1, X is 0, X is 1, and then X is 2. Remember, the absolute value of any number will always, always, always be positive. Okay, because it's really just saying how far is it away from the origin, from 0. Well, in this case, we have 1. The absolute value of negative 1 is 1 minus 4. So this is going to be negative 3. Let's do the 0. Absolute value of 0 is 0 minus 4 is going to be negative 4. And then the absolute value of 1 is 1 minus 4. You're probably seeing a pattern here. I hope you are. The absolute value of 2 is 2 minus 4, which is a negative 2. Okay, so now let's go ahead. We're just going to plot these x and y. We've got negative 1, negative 3. So remember, always go to your x-axis first. Negative 1 is going to be over here on the left. We're going to go down 3, 1, 2, 3, and there's our first plot, our first coordinate. Then we're going to go to 0, back to the origin. We're going to go down 4, 1, 2, 3, 4, and we're going to put our dot there. 2 more. So we got 1, negative 3. So we're going to go 1, and then down 3, 1, 2, 3, and then 2, negative 2. Okay, so if I were to continue to do this, what I would have is this half a square. This is actually a 90-degree angle, okay? And this makes sense because notice the negative 4 here, that's where the point is. It's where that intersection is. But you have values going to the right, which are positive, and you have values going to the left, which are negative. All right, this is the last example. So we did an absolute value. So now we have something that we called a quadratic equation. It's a quadratic because of this x squared. When you have an x squared, you will have a quadratic. So let's go ahead and do just like we've been doing right along. We're just going to come up with values of x, keeping in mind that we don't want to go too high because our graph goes only to 10 and negative 10. Okay, so I'm going to start really low. I'm just probably going to do negative 1, 0, 1, and 2 again. I'm going to plug this in here. Now keep in mind you have an x squared, so I'm going to plug in negative 1. I'm going to put this squared. Okay, and then this is going to be 0 squared, 1 squared, 2 squared. Okay, let's do the first one. So after simplifying, negative 1 squared is simply 1. Okay, because negative 1 times negative 1 is positive 1. So now we're going to add the 1. That'll give us 2. All right, 0 squared is 0 plus 1. Easy, it's 1. 1 squared is 1 plus 1, which is 2. And then 2 squared will be 4 plus 1, which is going to give us 5. All right, again, we're going to go ahead and plot these. Our x and y coordinates. Again, reminder, we're going to start at the x-axis. So we have negative 1, 2. I'm going to go to negative 1. I'm going to go up to my first point. Then we have 0, 1, going to the 0, and then we're going to go up 1. And then we have 1, 2, going to the 1, and then we're going to go up 2, and then 2, 5. And then we're going to 2, and then up 5. Okay, again, if I kept going in the positive and the negative direction, what I'm going to have is this curved line or curved graph. We call that a parabola. Okay, well, I know this video is a little bit long, and I hope you understood how to graph linear and nonlinear functions using a table. All right, everybody have a wonderful day.